शक्ति बल.
यस, बहुत बढ़िया. ओके, हाँ जी. सो व्हाट इज योर अंडरस्टैंडिंग ऑफ वर्क पावर एनर्जी?
No understanding.
नो अंडरस्टैंडिंग है. सही, दैट इज ऑल्सो वेरी गुड. नो अंडरस्टैंडिंग. So when do you think work is done? Very basic. Okay.
किसी चीज को मूव करने के लिए जो फोर्स लगती है.
Okay. Move तो कर सकते हैं, ठीक बात है. But it may not result in work as per the definition. So let me tell you. So what exactly is the definition of work? See, work is done when you apply an external force on the body. Okay. And as you said, the force results in displacement of the body, but with a condition that the displacement has to be in the direction of the force. Direction of the force. What does this mean? So if you have a block of mass, say 2 kilograms, this is lying on the ground, you apply a force of 10 newtons. Okay, and the body gets displaced by an amount of, and it's a constant force. Okay, so you're applying a constant force, and the 2 kilogram mass displaces by say 100 meters. Keep on applying a constant force to 2 kilograms, and after some time, using acceleration is equal to 10 upon 2, right? You can calculate the displacement. Finally, it comes to rest, and or maybe it is at some velocity at this point. How much work, and this was at rest here. Okay, and as it is accelerating, it may have some velocity depending on how much time it has elapsed. So distance elapsed is 100 meters. So v square minus u square is equal to 2as. V square minus 0 square is equal to 2 into 5 into 100. V square is equal to 1000, and v is equal to 10 root 10. So you know the velocity. Okay. Now if you notice, the direction of the force is rightward.
सर एक्चुअली हमने वेलोसिटी निकाली क्यों?
हाँ जी,
वेलोसिटी क्यों निकाली हमने?
just to tell you that what was the impact of applying the force. It changed the velocity of the body, and the body started having something called as a kinetic energy. मोशनल एनर्जी आ गई बॉडी के पास. ये किसी बॉडी के पास एनर्जी कैसे ट्रांसफर करोगे आप? व्हेन यू डू वर्क ऑन इट. ओके, तो इसमें जो सेंस अभी आएगी वो ये आएगी कि जो वर्क डन हुआ है इस सिचुएशन में, that is same as the kinetic energy which the body shows up. So if the body shows up a kinetic energy of 2 into v square, okay, so 10 root 2 whole square. So these are the number of joules which the body has acquired. But अभी ये point नहीं है, but ये बताने के लिए कि somehow the body which was at rest acquired energy, and that energy is possible only when work was done on it. But another more important point is that the work has been done because the angle theta between the displacement and the force is 0. Okay, so they are at 0 degree with each other. ये देख लो, फोर्स की डायरेक्शन ये है और डिस्प्लेसमेंट की डायरेक्शन ये है, दोनों के बीच में both are parallel and the angle is 0 degree. So somebody said, what is that you propose to do now? Okay, I said, okay, let me do one thing. Let me apply a force of 10 newtons now, but at 30 degrees. Okay, so this is 30 degree. This is 10 cos 30. and this is 10 sine 30. Okay, and this is a block, and maybe the mass is 6 kg, and this is weight. There is a normal reaction, there is no friction, and now when the body is pulled by a 10 Newton force on the x-axis, the what you apply is the force being used is F cos 30, okay, which is 10 cos 30. And you see that the body slides on the ground and maybe it covers some distance. Okay. And this time, however, if you notice, the horizontal component of the force has reduced, right? It will become 10 into root 3 by 2. So 5 root 3. And the same 2 into A. So the acceleration has gone down from what it was earlier. Okay, it was 10 root, it was 5 earlier, and now it is 5 root 3 by 2. 5 into 0.866. So the velocity gain of the body will be less. If you do a V in the x-axis, if you do the same calculation using this acceleration, your final velocity will be less, and your final kinetic energy after maybe 100 meters again will be less. Point being made is, since there was an angle between displacement and force, this is your force and this is your displacement. If there is an angle between them, then what you realize is the work which you do still gets done in the x-axis but gets reduced, because now the body does not acquire as much velocity as it did. So the energy gets transferred to any body. If this is a body, you transfer it some energy. Okay, the only way to do is to do work on it, which means a constant force being applied on it that gets converted into energy of the body. So this conversion happens. So the way to see the work is actually to observe how much energy the body has acquired. This is one. And as the angle will go up, as the angle goes up, what you realize is less amount of energy is observable. So the body shows less and less kinetic energy or motional energy because of the applied force, because the angle is reducing, which means the work which is being done is continuously going down as the angle between force and the displacement is increasing. At a certain point, when theta is equal to 90 degree, where you apply a force like this, obviously the displacement, assume you carry something on your head. Okay, this is your head, and that whatever it is has a weight being exerted on you, which is Earth's gravity, and you push it back with an external force, which is your normal reaction to the block from your head. Okay, and you move through a distance of 100 meters and you get very tired and you say, I have done so much work. But if you talk about work, actually, as per physics, if you were moving at 10 meter per second continuously and you're still 10 meter per second here at some point, and you're still carrying this on your head, then you feel very tired. The force, this force, which is the normal reaction acting on the block, and the displacement of the block are at 90 degree. What we will say is that the work done by this force is zero. The man has done no work, although he is very, very tired, because the force is being applied on the block in such a way that it is perpendicular to the direction of the displacement, S. So whenever you see a 90 degree angle between force and displacement, theta is 90 degree, the work done is zero, which means actual definition of work done is, it is basically the dot product of F and S, which means it is force
It is
multiplied
scalar
by,
and vector.
Yes.
स्केलर क्वांटिटी है,
Scalar. This is a dot product.
तभी
Okay.
पूछ रहा था.
Okay. Into cos of theta. What is the meaning of the word dot product? This is what it means. If you have two vectors, okay, A and B, and you want to find out what is a dot product of these two vectors, which means vector multiplication in a certain manner. What you're saying is pick up vector A, find the magnitude of B in the direction of A, which means what is that component of B which is parallel to A? That component is B cos theta. Iska component, okay? So one component of B which is parallel to A is B cos theta. The one which is perpendicular to A is B sin theta. Okay? The multiple, the algebraic multiple of A and the parallel part of B, so this is B parallel, is called as the dot product of two vectors. Okay, so these are in same direction. B cos theta is in same direction as A, and similarly if you notice F dot S, and this is F and this is S, and there is an angle between them, the component of force which is in the direction of S is F cos theta, the projection of F on S. F sin theta bhi exist karta hai, plays no role in work done because it is perpendicular to the direction of displacement. Displacement is in this direction, whereas F sin theta is perpendicular. No contribution. F sin theta has no contribution, but F cos theta has a contribution. So force into displacement into cos theta actually is force and cos theta, which is the horizontal component of force, is getting multiplied with displacement to give you work. They have to be in the same direction. And the F cos theta, this and this, which is this particular part, is the green part I'm showing you. That part of the force is in line with S. Okay, so F cos theta into S. The component which is along the displacement and its multiple. This is normal multiplication. So we'll give you the work done in joules. Okay, so this is in Newton meter, can also be written as Newton meter, but this gets confused with torque. So avoid it, use joules. And work will finally result in, you will see, because there is a constant force involved, you are going to accelerate the body and its velocity will continuously increase, and therefore the work will get converted into kinetic energy. This is the way it gets converted into kinetic energy. But for the time being, the main point you have to understand is, if you get a question on work done is F dot S, it is scalar product or a dot product. And what does it mean? It means the component of the force which is in line with the displacement only contributes to work done. The F sin theta component into displacement, because theta is 90 in that case, contributes nothing. So work done due to the Y force, which means it is perpendicular to the X displacement, is 0. So only just take Fs cos theta, where theta is the angle between force and displacement, to be your answer as a work done, and it's a scalar. ठीक है जी? Any doubts in your mind pertaining to this concept?
एक मिनट.
Clear?
हाँ जी.
All right. Now, one of the most confusing topics of this chapter is the concept of positive work and negative work, okay, which is in fact more to do with understanding of angle. So there is something called as a positive work and there is something called as negative work done. Now, if you see, positive work means actually, very simplistically speaking, as a layman, the velocity increases. Okay, which means the force which you apply gets converted into positive work, which means the work done gets converted into an increase of kinetic energy, which is generally possible. If you notice, F S cos theta, and I want a positive work. Force is what it is, S is what it is. Theta is going to be instrumental in deciding the negative or positive work, okay? Which means in the first quadrant, okay, in the first quadrant, if you're in the first quadrant and this is your force, this is theta, then the component of force which is parallel to displacement, this is displacement, is F cos theta. So the product will be positive because cos theta is positive. But imagine a scenario where the force is getting applied like this, theta is
Negative हो गया.
obtuse, and this is something like a friction, right? So the force of friction will not increase the velocity, usko rok dega wo, right? So this is your force of friction, or maybe some frictional force, some opposite force. You're trying to stop some body, right? So you're trying to decrease its kinetic energy, something like that. So if you notice, this body is displacing towards this direction, but someone is trying to decelerate it or stop it. So F and S are in opposite direction. So F and S are anti-parallel, whereas here F and S are parallel. This is a concept of positive and negative work. So whenever you see a body which is getting slowed down because of friction, for example, you know, body has a tendency to move forward, the friction is going to move backward, and therefore this frictional force multiplied by the displacement of the body before it comes to a stop, maybe it covers some distance, S, but you will write a cos of 180 degree here. And cos of 180, which is anti-parallel, will give you a negative sign. And automatically it will mean that it is negative work. If you understand it directly, you can straight away write a negative sign. But if you want to do it with the help of an angle, please use cos of 180. Here, please use F cos positive angle, whatever exists. If you want to put some other angle also, which is in second quadrant, it will give you a negative answer only. So this is from 90 to 180. Everywhere cos is going to be. But then don't write force in the sign convention sense. Yes, these are magnitudes. Just write the magnitudes of these and rely on the cos of angle to give you the sign. Because if you say the force is leftward, you may like to put -5 newtons. And the displacement is rightward. So you may like to put 2 meters. And then you may again put cos of 150 degree. Don't do this. Because these are then magnitudes. Don't worry about them. Just put A magnitude, B magnitude, and let cos decide whether it is positive work or negative work. So these, I will just correct this, okay? All of this is magnitude, okay? Magnitude of F and magnitude of F, which is what I wrote here, okay? These are magnitudes. We don't have to do doubling of minus. Maybe the displacement is leftward and the force is rightward, but you don't write -2 meter and 5 Newton and then again put cos of 180. Don't do that. Just say 2 into 5 and cos of 180. Let angle decide the sign of the work. Make sense?
Yes.
All right. Okay.
So basically ये angle पे depend करता है.
Exactly. Okay.
Okay.
And you have understood, right? If you, for example, take an example of circle. Okay, let's talk about a circle. In a circle, what is the work being done by the centripetal force? You have this circle. Okay. What is the work being done by the centripetal force?
0.
By the centripetal work, because it is at 90 degree with displacement, right?
नहीं actually linear displacement भी 0 ही होती है.
हाँ, वो तो यहां से यहां तक भी अगर जाओगे, अगर आप every point, what is the direction of the force?
towards the center.
Towards the center. And velocity?
uh, Tangential.
90 degree हो गया ना ये.
हाँ.
So if you write, uh, for example, work done generally is written as F dot S dot, right? ये होता है ना F dot S. इसमें अगर मैं बात करूं, I can write it as F V into delta T. And say I'm writing magnitude. S is V dot delta T, right? Displacement. Multiply by cos of 90, because velocity and force are always at 90 degree. So there is this displacement, right? But at every point, if you notice, so which means this work is not zero because your displacement is zero. You're back to the same point. This work is zero because at every point the velocity and force are making an angle of 90 degree. मैंने लिखा F dot S था, displacement हुई है. मे बी पूरा सर्कल नहीं काटा आपने, बट S को आपने लिख दिया V into T, where V is perpendicular to. So in a circular motion, because the force is always perpendicular to the velocity, the answer is zero. Not because in circular motion you are covering the whole circle and displacement has become zero. That logic is wrong. वो displacement का logic है. Even though you have moved a very small amount of displacement, your work done is still zero by the centripetal force. Which force is doing work? किस force का work done पूछा है, वो भी important होता है, क्योंकि हो सकता है इसके ऊपर और भी forces लग रही हो, तो वो वाली forces काम कर रही हो, but centripetal force कभी भी काम नहीं कर रही है. Does no work. Because it's a case of uniform circle, remember. If the force is changing, then the velocity will change. But the velocity in a uniform circular motion never changes, which means if the uniform circular motion, the velocity never changes, the symptom of work being done, half mv square, will change. But since velocity is constant, the kinetic energy of the body remains same. The only way to change the kinetic energy of the body is to do some work on it. But it's a uniform circular motion, the velocity never changes, and therefore the work remains same.
Okay.
Questions? Right?
Yeah, in the case of uniform circular motion.
Yes. Uniform means velocity is not changing. It is changing in direction only. But even though it changes its direction, centripetal force always remains perpendicular to it, irrespective.
ठीक
है. Okay. Now in certain questions you will find that the velocity is, the work done is expressed as, let me just write it. Okay. The work done is expressed as, in units, I mean joules. Okay. And this is your SI unit. And if you want to convert it into ergs, which is the CGS unit, okay, so this is 1 Newton force displacing a body of 1 meter in the same direction, will mean 1 joule. 1 erg is when 1 dyne of force displaces a body by 1 centimeter. Okay, so you can convert newtons into ergs. And हाँ जी.
एक न्यूटन में कितने डायन होते हैं? डायन.
So 1 Newton is how much, right? 1 kilogram into 1 meter per second square, right?
अच्छा.
So 1 kilogram is 1000. This is 100. This is 100, right? मैंने सेंटीमीटर को भी कन्वर्ट कर दिया, तो you can see न्यूटन के तो आ गए 10 raised to power 5, right?
एक
So
डायन.
1 Newton is 10 raised to power 5 dynes.
डायन.
ये रहा ना, किलोग्राम is grams.
ठीक है.
and then another 100 centimeter, right? So this becomes how much? This becomes Newton,
10
and this
power
becomes
7. 10 raised to power 7
yes. So 1 joule is going to be 10 raised to power 7.
erg.
Erg is the right unit, not ergs.
Erg जो भी होता है.
Correct. Okay. Another. Okay, I'm going to the next page. I think we're done with the ink of this page.
नहीं इंक नहीं मतलब
नहीं, वो
उतना नहीं
स्टोरेज
पता.
होती है यार, वो स्टोरेज होती है उसमें. The storage gets exhausted on a page and
इरेज कर दो मैं पूरा ये.
नहीं नहीं चलने दे यार. कौन 10 मिनट लगा के उसे इरेज करेगा?
नहीं 2 मिनट में कर 1 मिनट में कर दूंगा.
Okay. Work done by the so work done in terms of vector algebra अगर आता है,
कर दूं
so
ना
say,
इरेज.
अरे यार don't waste time on that, just focus here. Plus say force is given by this, okay, plus ck, and the displacement is okay, so the displacement is a2i plus b2j plus c2k. You have to calculate the work done, and it is given by
एफ
F
डॉट एच.
dot S, okay,
डॉट
which is
प्रोडक्ट वाला
magnitude of
फॉर्मूला.
F into magnitude of F into cos of angle between. But ये तो वेक्टर में दे ही रखा है, तो we will do A1I
ए2
हाँ B1J plus C1K multiply by A2J plus B2J plus C2K is equal to A1 A2 plus B1 B2 plus C1 C2 joules. So work done in rectangular components, or you can say work done using vector algebra. Okay, ijk. I dot I is
ये अपने बता
magnitude is
रखे हैं.
1, 1 and cos of 0. So this is 1. So similarly, j dot j is 1. K dot k is 1. But I dot j is magnitude 1 into cos of 90 degrees. So this is 0 joules because they're at 90 degrees. Right? So ये इसी से आ गया आंसर. Okay, let's do some numerical using this concept. Okay, work done के concept से. I think NCERT will have some great questions.
नोप नॉट एट
No?
ऑल.
कुछ
ना
नहीं है?
रद्दी.
Okay.
उससे बढ़िया एसएलआर उड़ा में.
Okay.
सर एनसीईआरटी वो कंसेप्चुअल क्वेश्चंस में टेस्ट करती है ना कि न्यूमेरिकल्स पे.
हाँ जी.
एनसीईआरटी आपको कंसेप्चुअल क्वेश्चंस पे टेस्ट करती है.
कब हुआ है?
वो मतलब क्या कहते हैं एनसीईआरटी के जो क्वेश्चन होते हैं
हाँ हाँ
वो कंसेप्चुअल क्वेश्चन ज्यादा होते हैं.
हाँ.
न्यूमेरिकल्स कम होते हैं उसमें. लाइक बेसिकली 30%.
Okay. Got it. All right. तो एक बंदा है वो a man climbs a staircase of so this is given to be 1 and this is 2 meters. Okay. So he starts from here and his weight mass is 75 kg and he starts from here and reaches here. How much work has he done in moving across this? And this total is 1 meter. ये 1 meter है height or 2 meters. How will you tell the work done by the man? Yeah. And he moves with a constant velocity when he's going up.
Okay. Constant velocity, it means the acceleration is 0.
Hmm.
So, 0.
There is no friction, nothing.
0 होना चाहिए, 0 joules.
0 joules. उसने क्या why so?
आपने constant velocity बोला ना.
हाँ, ठीक है, कांस्टेंट वेलोसिटी से गया फिर.
Constant velocity मतलब acceleration 0 होती है.
ओके.
तो force भी जो 0 लगेगा.
ओके. राइट, ट्राई एंड राइट द इक्वेशन. So you're saying there is no external force, right? There is no external force, right?
No.
Okay. So he has done no work as per you.
But he has moved 5 meters.
He has,
He has moved root 5 meters.
uh,
Displacement तो पर हुई है.
but has he, so what is the work done on himself? अपने ऊपर कितना काम करा है इसने? चलो ब्लॉक पे कुछ नहीं करा मान लेते हैं, ठीक है? He has done no work on the block. How much work has he done on himself? Okay, so I think थोड़ा सा भी advanced level question है, but broadly, okay, we will go with your thinking for the while that the work done अपने को ऊपर ले जाने में you are saying to take himself up, although horizontal. If I see what is this resolution of forces, if I do, okay, so this is 75 kg, and he's being pulled down by a force which is what, 75 g sine theta. We know tan theta is 1 by 2, and sine theta therefore is 75 into g into 2 by root 5, right? So this is the force acting. So he works against this force, right? And moves with the same force to oppose this, and is able
mg
to
sin
go
theta.
up. हाँ
mg sin theta.
हाँ हाँ, वो तो लगी रही है ना उसको नीचे लाने के लिए हमेशा. तो ये खुद को उसी को तो ओवरकम करके ऊपर जा रहा है ये. That is why he's at a constant velocity, right? Balanced force है. So whatever is this force is the force he's applying. Maybe he's pushing the ground, then the ground is providing him backward force
ठीक
as
है.
a reaction, right? So he does have a situation of balanced force. इधर भी इसको नीचे ले रहे और एक खुद भी अपनी ताकत लगा रहा है जाने के लिए, right?
इक्विलिब्रियम में.
हाँ, sort of equilibrium,
अच्छा, ओके, मैं समझ गया. ठीक है.
right? So he if you notice this 1 meter height, right? So you can see the whatever forces you're applying, there is an angle which the force, but net force is 0 because he's at constant speed. Yeah. So thoda sa different hai, but let's start with some simple questions. I will come back to this once your concept is more strong. That if you push a block, okay, you have this situation of an incline, and this is your mass, and you are a man who is standing on the ground and pushing it with a force of 5 Newton, and it goes up. Okay, then how much work are you doing on the block? Obviously, same concept has to be used. But remember, इसमें अगर मैं coordinate system same ले लूँ, right? मेरा coordinate system अगर ये हो जाए कि so mg net mg sin theta भी आ जाए और मैं सब्ट्रैक्ट करके 5 mg माइनस साइन थीटा कर लूं, दैट इज अ नेट फोर्स एक्टिंग अपवर्ड्स, एंड द डिस्प्लेसमेंट इज ऑल्सो इन दिस डायरेक्शन. मे बी द डिस्प्लेसमेंट इज 2 meters. Then the net force in the new rectangular component multiplied by the displacement will give you the work done.
ठीक है.
Got it ना? मतलब वो डिपेंड करता है सिचुएशन पे. We will come back to inclined plane and all that later, but let's do some very very simple type of questions to start with. So let's say you have there is a man who is having okay, so मतलब बहुत simple है यार इसमें. There is okay, yes, this is good. So there is a man who is weighing man's weight. Okay, so let's say question number two. The man's weight is given to be say uh, 50. Okay, and uh, he carries another weight on his head which is 25 kg. Okay, so this is the on his head, and he moves through a distance of 20 meters, and this is the incline. Same question. This is the incline, and the incline is 1 is to 10. Let us see. Okay, the question is what is the work done when he moves through a distance of 20 meter?
Work done on himself or the box?
Total work done. If he carries it on his head.
अगर on the box है तो वो 0 है.
देखो.
अभी 20 मीटर्स बोल रहे हो सर?
Yes.
तो 20 मीटर्स नहीं होना चाहिए.
Calculate करो यार, देखो क्या आता है. He
पाइथागोरस.
does move 20 meters,
नहीं नहीं.
and just give me 1 second here. I don't know who is this. हाँ जी. ठीक है, 110 हो गया.
कांस्टेंट वेलोसिटी से जा रहे हैं ना
हम्म,
ऊपर की तरफ।
हम्म। Just be very careful that who is doing the work is a big question. Okay, if you see the weight, this force, okay, which is and he's applying an equal force.
यस
अगर मैं इसको उल्टा कर दूं कि देर इज अ incline and now there is a block, it is coming down due to mg sin theta. Okay, there is no man involved. अभी man involved नहीं है, अब सिर्फ एक ब्लॉक है और वो ब्लॉक नीचे की तरफ जा रहा है. If the block is going down and the displacement is in the same direction, then it will accelerate, right? mg sin theta तो acceleration है ना?
यस हाँ जी
नहीं समझ में आया?
नहीं ठीक है एम sin थीटा एक एक्सेलरेशन है
So if it is going down automatically with mg sin theta, then work
ओके
will be done by the weight. The weight, which is a force, will do work. And which component of the weight will do work? Which is mg sin theta. So mg sin theta into whatever is the length of the ramp, और जो भी जितना भी travel करा, into s. Right? Angle
तो
between
मैं
them
ऊपर
is,
की तरफ ले रहा हूँ
हाँ
मैं ऊपर की तरफ ले रहा हूँ
हाँ. इधर क्या हो रहा है? Since there is a downward force which is pulling it down, he's not going automatically downwards. The question is incomplete. The question should say, in order to move up, he is applying an equal force. Okay, and maybe whatever force is coming here, he's applying the same force against the weight component, right? And is going up. So the overall he's not accelerating up, he's moving with constant velocity. But the question, if you notice, is silent, right? There is no mention whether he's moving with acceleration or so. Real work, positive work, will result in increase of kinetic energy, which is what happens here. जब आप नीचे आते हो ढलान से तो आपकी स्पीड बढ़ जाती है, just because you are in the same direction, but you are at constant velocity, right? You are in the, so you are also applying a force here, but you are at constant velocity, which means whatever force you're actually applying adds no value to your velocity. The work done will still remain zero, because work done should result in something, right? Some people may argue that this may result in increase of potential energy of the body. So body is gaining height. Body is gaining height. So we have gained this much energy. So the energy gained is mgh, and that has come from the work done. Whatever work was done has got converted into its potential energy. So work done can either result in increase in potential energy or increase in kinetic energy of the body, gets stored in that format. So this is a typical case where though the velocity is constant, there is a gain of potential energy, which means whenever you do work, you either are increasing the height of the body or you are increasing its kinetic energy. I mean, when you're doing positive work. So therefore, when we try to apply the rationale of velocity here, हमने potential energy भी पढ़ा नहीं ना, पूरा work done नहीं पढ़ा. So although velocity standpoint, there is no work done, right? That is the impression we carry, that work done will result in gain of half mv square. But work done can also result in gain of height, mgh. 9th standard में पढ़ाते हैं mgh. So you have to evaluate the situation. Am I gaining any one of them? Although on the face of it, there is no gain in kinetic energy, and apparently the temptation is to apply the concept that there is no work done and the work done is zero. It is not, because there is a gain in potential energy. But अभी इससे दूर है हम थोड़ा सा कि how the work is being done. Now, if we apply the rationale of angle in this, It is wrong because angle is fine. दोनों so इसलिए अगर आप देखो the work done mgh will come. So if you calculate this mgh, which is a gain in height, if the mass is known to you, g is known, into h karoge, that actually is a work done, and it is moving with constant velocity, which means the total work done, is mgh. Some part gets converted into potential energy in some cases, and the balance may get converted into kinetic energy. So and sometimes this is zero, this is complete, this is zero, and this is full. But sometimes both can be accomplished. You may accelerate upwards, your velocity is increasing, and also your potential energy is going up with respect to Earth. MGH is also increasing. But abhi thoda dur hai. I think it's come a bit too early. Right? So those standard questions are okay now. Okay to do. जिसमें वो डॉट प्रोडक्ट लेना है या cos 30, cos 40, cos 50 से करना है. Got it?
Okay.
Okay. So let's say. So work can show itself in multiple formats. It can show itself in multiple forms, not necessarily just kinetic energy logic to be applied. Okay, let's say some questions in work done are based on the concept of the concept of variable force, where the force keeps on changing. So there, if you wanted to calculate work done, what you have to do is move the body through a very small amount, do a very small amount of work, and then integrate. Where F may be given to be some, F is dependent on displacement. So the more you displace, the more work gets done. So X is the location coordinate on the X-axis, and it is given to be this. Or displacement is in X-axis. So you say, okay, force is 2x into dx. So कितना move करा आपने 0 to 5. तो बोला जी 2x square by 5. Sorry, 2 integral 0 to 5 is equal to 5 square minus 0 square is equal to 25 joules. You moved a small distance of displacement dx in the direction of the force, but the force is continuously changing at every point, and therefore you can't directly multiply. You take the concept of integration. Okay, so variable force jab bhi dikhe, please apply integral. These are basics. Questions will follow. What exactly it means? Integration, area under the curve, which means if you have a force versus graph, displacement graph, and you're being asked to calculate the area under this. For example, ये तो constant force, ये variable force है, right? ये force लगातार बढ़ रही है और net displacement भी हमें मालूम है. If you calculate this area under the curve, it is same as calculating this. You can see maybe the force is given by equation. It's a positive slope, so maybe 2 plus 5x Newton, and this is your displacement x. So the work done is integration of 2 plus 5x dx, and you can say kahan se kahan gaye? 1, 2, 3. So 1, 2, 3. The other way could be if you know this values. So at x equal to 1, the force is going to be 7 Newton. At x equal to 3, the force is going to be 17. So we know the coordinates of these points. So this is 3 comma 7. This is 73 comma 17, and this is 1 comma 0. This is 7, 1 comma 7. So if we know all of these, we can calculate the area under the curve using the concept of trapezium, or one triangle and one rectangle. It will fetch you the same result as this. जो इंटीग्रेशन से आंसर आएगा वो एरिया अंडर द कर्व से भी सेम ही आंसर आ जाएगा. फोर्स इज वेरिएबल, दैट इज द ओनली डिफरेंस. सो लेट्स डू सम क्वेश्चंस ऑन सिंपल क्वेश्चंस. ये थोड़ा सा इंटरेस्टिंग टॉपिक है करने के लिए. सो लेट्स से यू हैव दिस सिचुएशन वेयर यू हैव okay, 1, and then you have, so this is your force versus x graph, obviously displacement versus force hai. So this is your force versus x graph. This is 10 and this is minus 10, and this is x tending to infinity. Okay, this is x-axis. The question
ये
is,
और ये क्या है?
okay, so this is 1, this is 2, this is 3, and this is 4
ठीक है.
in meters. This is in meter. Be very careful that here the directions of force
Yes.
and x, this is negative area, right?
Hmm.
But work is a scalar, remember. So,
Sir, work done would be
हाँ
10 होगा work done.
कैसे भाई?
Area under the ground.
कैसे कैलकुलेट करा?
रेक्टेंगल वाले फॉर्मूले से 10 into 1
हाँ
10 आ गया. फिर इसको भी ऐड कर दिया.
10
10
और
plus
एक
10.
-10 नीचे है,
हाँ,
ठीक है? So 20 minus 10,
10 meter.
right? So this is 10 joules coming from 10 into 1. This is 10 newtons. This
Total
is
work would be
displacement
10.
of 1 meter. This is on the negative side. So this becomes minus 10 joules. This is again a constant force of 10 newtons and a displacement of 1 meter. So this is F into 1. So total is 10 minus 10. मतलब एग्जाम में लिख के आना है पूरा. This is not MCQ. Okay. All right. So let's say another question. The force is given by question number 3. Variable force के ऊपर ही है. 15 plus. Sorry. Let's do. Okay. So let's say the force is given by A plus bx. It's a variable force. Immediately question में देखना है x आ गया कोई b के साथ. Okay. And the work done is to be calculated, and the displacement of the body is from x equal to 0 to x equal to d. Question is, what is the work done when the body moves from this point to this point? You do this. Calculate it. So two types of questions. One, area under the curve. Others is variable force with equations, which is integration. मैंने थोड़ा जल्दी इंट्रोड्यूस कर दिया आइडिया ऑफ एनर्जी बिकॉज मुझे लगता है दैट्स अ बेटर वे टू स्टडी. अदरवाइज पीपल आर जस्ट कंफ्यूज बिटवीन एंगल्स एंड एक्सेट्रा कांस्टेंट वेलोसिटी.
इसमें हमें इंटीग्रेट करना पड़ेगा.
करो, इंटीग्रेट करो. यू नो हाउ टू इंटीग्रेट नाउ. यू हैव लर्नड इट.
की लिमिट्स है इंटीग्रल की. 0 इंटीग्रल की लिमिट्स है.
पहले एक्सप्रेशन तो लिखो यार. एफ डी एक्स, इंटीग्रल ऑफ एफ डी एक्स. हाँ सही है, ठीक है.
एकदम पर b से
यू
0.
मीन एक्स इज इक्वल टू 0 टू. हाँ ठीक है, सही है, करेक्ट है.
हाँ जी.
नथिंग रॉन्ग.
सर आपने एसी चला दिया क्या?
नहीं,
आवाज आ रही बड़ी गंदी.
नथिंग.
निकल गया सर वर्क डन।
हाँ जी,
वर्क डन निकाल दिया।
ओके, गुड है। गुड, okay, let's try something else now. Okay, all right, so let me introduce you to the idea of, so this is work. थोड़ा सा मैंने आपको हिंट दे दिया एनर्जी का. Okay, so let's talk about energy because we have to link work and energy finally with each other. हमें इन दोनों को आपस में जोड़ना है, energy और, तो what is energy? Okay, the capacity of the body to do work. Okay, the capacity of the body to do work is called as,
सर थोड़ी
so
आवाज
it's,
कट रही है आपकी, एक बार
you speak louder.
सर आपकी थोड़ी आवाज कट रही है अभी, तो कुछ नॉइज आ रहा है आपका।
So maybe internet की problem हो. So energy is the ability to do work.
ओके।
Okay? And the energy we are interested in is not heat energy, not electrical energy. The only energy we are going to study in this chapter is
मैकेनिकल।
mechanical energy. Mechanical energy has two parts. One is potential energy. The second part is kinetic energy. There are two parts to it. Okay, these are the only two which are included. What is kinetic energy?
हाफ
The
एम वी
energy
स्क्वायर।
possessed by a body by virtue of its motion, which is
ठीक है।
velocity, half mv square, right? The, sorry, ये kinetic होती है. Let me just interchange them. So, motion की वजह से it's kinetic. Okay? The energy which is possessed by the body by virtue of its position, like ground से कितनी ऊपर है, with respect to planet. Planet से कहाँ पे हो आप, right? So that decides your position. By virtue of position with respect to the planet's surface, how high are you will define its potential energy. So the way to work this through is, if you know there is a, so let's talk about the idea of kinetic energy first and say what is kinetic energy's expression. Obviously it is v square minus u square is equal to 2as and all that. If you have to calculate the work done, then force into s into cos of theta. Supposingly the body is in the same direction as the acceleration. So the force will be m into a into s cos of 0 is equal to m into v square minus u square upon 2s multiplied by s into 1. So ss will get cancelled. Initial velocity was 0. So the kinetic energy of the body after it is accelerated through a distance s is half mv squared. So this is the expression of kinetic energy, that the work done appears as kinetic energy. Okay, so whatever work you have done has appeared as kinetic energy of the body. Okay, and you can say momentum of the body at that instant is mv. So p square is equal to m square v square. पिछले चैप्टर में मोमेंटम पढ़ा था हमने, and if I say p square by m is equal to mv square, so multiply both the sides by half mv square. So work done can also be written as p square by 2m. Not only half mv square, but suddenly I have introduced that there is another form. Sometimes you get a numerical, the momentum is known to you, the mass is known, they ask you to calculate the work done to achieve that momentum. Okay, so these two forms are allowed. This is squaring both the sides, taking m below and multiplying by half. So this is your kinetic energy. So kinetic energy can also be written as p square by 2m, and it is coming from a source which is work done. Right? So if you have a constant force, you can always see that a constant force will do work, will change the velocity at constant acceleration, and therefore work will actually, इसमें तो we took the initial velocity to be 0, but it is not true always. You may have an initial velocity of 2 meter per second, and then I apply force on you and increase your velocity. So you may become half m v final square minus vi initial square. So work done results in gain of kinetic energy. So delta Ke, or you can say change in kinetic energy. If the work is negative, this will come out to be less than 0. If the work is positive, it will increase the kinetic energy of the body from the velocity u, initial velocity, to the final velocity, which is what we do in the case of constant. So if I multiply both the sides by half m, right, I will get the answer. If I see this equation of motion, I multiply it with half m, I will get, this is final kinetic energy, this is initial kinetic energy, is equal to, if you notice, ma is force into displacement, and these two are, here the acceleration and velocity are linear in the same direction. So
So can we
displace,
say
huh?
so can we say that delta Ke is equals to the work done?
Correct.
So
If you
मतलब
apply,
अगर हम
yeah, says, go ahead, sorry.
काइनेटिक एनर्जी का अगर हम डेरिवेटिव ले तो हम उसका वर्क डन आ जाएगा कैसे?
Kinetic energy final minus kinetic energy initial will give you the work done. So if I say a body has initial kinetic energy of 10 joules, after some time you see 50 joules, what is the work done?
Work done is 40 joules.
Yes, the difference. So the
Okay.
work was pumped inside that body. Pumping of work inside the body. Mechanical work was done. Mechanical work will either result in increase of kinetic energy or in change in position of the body. यहाँ पे हमने बोला कि it has resulted in change. अब वो सिर्फ change ही बताया है. 50 kinetic energy बताई है तो ठीक है. Kinetic energy ऐसे work position भी बदल सकते हो आप इसकी.
ठीक है.
So irrespective of type of force you have, whether it's variable or constant, if it's a variable force, the work done by a variable force can also be written as delta Ke. The initial and final are more important. And in the case of a constant force, also the work done is equal to delta K. It doesn't matter which force is involved. Just worry about initial and final, and what is the net change will tell you the work done. It doesn't matter whether the interim force was variable or constant. कोई फर्क नहीं पड़ता उससे. Okay, let's move forward on this and try some questions based on our knowledge of kinetic energy. Okay, so let's say there is a body. Okay.
सर एक बार अपना हेडफोन दोबारा रिकनेक्ट करके देख लोगे?
Uh-huh.
कर दिया.
कर दिया.
सर? ठीक है.
ठीक है. So let's say you have uh, let's do one question. So there is a bullet, okay, which is getting fired. Okay, so question number 1 on the concept of kinetic energy, which is delta Ke is equal to work done. That is it. Simple. So you have a bullet which is 10 grams, okay, and that bullet is fired with a velocity of 800 meter per second. So you know it's a we'll watch is the initial, and it gets inside a muddy wall. Okay, so this is your muddy wall through which it enters, and then it stops after some time. Not stops, or maybe it stops. Okay, or the velocity reduces to finally when it is going through this. Assume that the average acceleration or deceleration is constant, is given by 100 meter per second. Okay, and this is 1 meter. So after 1 meter, the velocity has gone down. You have to calculate what is the force, the kind, so to say, the friction being applied by the muddy surface inside. जब बुलेट उसके थ्रू पास हो रही है ऐसे, तो वो उसको रोक रहा है. You have to find the value of that frictional force which is decelerating the body, and assume it's on an average everywhere it is same. Don't do it from the perspective of this is 1 meter, by the way. So the loss of velocity, assume this resistance which is being offered, or the so-called friction being offered by the muddy surface, is constant throughout. It is not a variable friction. So you can see the net, there is a loss of kinetic energy. You've lost.
And calculate the work done, delta KE.
Correct. Just be careful that 10 grams is converted into kilograms.
This is a final है.
हाँ जी, कम हो गई है 100. Sorry, initial is U. This is, let me just name it VI, and this is U is final. Okay, उल्टा लिख दिया वैसे V और U के सबस्क्रिप्ट में, but let's correct it. So half mv square. ये force और energy क्यों बराबर कर दी? How is force equal to energy now?
Sorry, force नहीं.
The work done by the frictional force.
हाँ जी, sorry.
उसी ने काम करा ना रोकने का.
हाँ.
Negatively impact करा आपको. You have lost.
The force would be 1 meter. Sorry, 3150 Newton.
Negative sign आया force में.
हाँ जी, negative है.
So it shows that it is oppositional to displacement. Displacement तो इस तरफ हो रही है ना. Frictional force ऐसे लग रही है. Got it?
Yes, sir.
So इस force ने negatively impact करा है, ऐसा work करा है कि kinetic energy को reduce कर दिया. Okay? All right, so you have question number 2 again from NCERT. So you have some raindrops falling downward under the influence of gravity, okay? ऐसे रेन ड्रॉप्स गिर रही हैं, और हवा से उनको दे आर गेटिंग फ्रिक्शन फोर्स ऑल्सो. Okay, so the weight is this, and this is the frictional force coming from the air.
ओके.
जो होता भी है, if you cut through air, the air molecules will apply a force on you
तो ये
backwards.
रेजिस्टेंस नहीं कहते?
Air resistance. Okay, so now it is known that the frictional force which is being applied on the drops is proportional to the square of the velocity. Higher is the speed of the drop, more is going to be its frictional force it faces. Okay, so this is known. And let's say there is a pebble of 1 gram which is falling. तो ये 1 ग्राम की ड्रॉप है जो नीचे की तरफ आ रही है, और it is coming from a height of, say, starts from 1000 meters from here, okay, and it is coming down. And then what you realize is it has hit the ground with a velocity of 50 meter per second. The question is, what is the work which was done by the frictional force, not by the gravity? Okay, gravity का नहीं पूछा है इसने. इसने पूछा है ये जो फ्रिक्शनल फोर्स है इसने कितना काम करा है. थाउजेंड मीटर से आ रही है, गिर रही है. सो देर आर टू, इफ यू हैव अ बॉडी लाइक दिस which is being acted by one force and a second force, two forces, both the forces are doing their own work. Obviously your displacement is in this direction, and therefore you are, maybe you started with a zero velocity, or जो भी आपकी शुरू में velocity थी, it started from rest, right, and यहाँ से जीरो से गिरे आप, बट यहाँ पे 50 मीटर पर सेकेंड है. तो दोनों फोर्सेस अपना अपना वर्क डन करती हैं, अपना अपना इन्फ्लुएंस लगाती हैं. एक ऑब्वियसली जो है वो उल्टी डायरेक्शन में काम करी है, रेजिस्टिव इन नेचर है. दूसरी जो है वो along the displacement है, which is weight. So weight is also doing work, and this resistance force is also doing work. You calculate this work separately, that weight कितना काम कर रहा है और ये कितना काम कर रही है रेजिस्टिव फोर्स, और नेट जो बॉडी में चेंज आया है, इट इज बाय वर्च्यू ऑफ टू वर्क्स बीइंग डन, वन बाय द ग्रेविटेशनल फोर्स एंड वन. तो आपको वो वाला हिस्सा निकालना है जो फ्रिक्शनल फोर्स ने दिया है as a work done. Obviously it's negative, it's not positive. Just think, थोड़ा सा think through this. You know the proportionality. So पहले तो work done निकालो by gravity. This is also a force, and what is the work being done by the gravity? पहले वो निकाल लो. What is your concept? Delta Ke, right? This is what you're worried about. Finally तो दोनों ने यही करा ना, चेंज इन काइनेटिक एनर्जी. दोनों फोर्सेस ने नेट क्या दिखाया है? चेंज इन काइनेटिक एनर्जी. एक फोर्स और दूसरी फोर्स, उनका अपना अपना वर्क डन है, जो वो दे आर प्लेइंग देयर रोल्स, दे आर गिविंग देयर कंट्रीब्यूशन, दोनों अपना कंट्रीब्यूशन दे रहे हैं काइनेटिक एनर्जी में. लेकिन नेट रिजल्ट क्या हुआ कि काइनेटिक एनर्जी जो है फाइनल या इनिशियल इज जीरो एंड दिस इज फाइनल, राइट? सो चेंज इन काइनेटिक एनर्जी इज हाफ mv². So half m, whatever 1 ग्राम दिया हुआ है, 1000 मल्टीप्लाई बाय 50². दोनों बॉडीज ने कुछ भी कराओ, द नेट चेंज इन काइनेटिक एनर्जी इज known to you. Also, if you notice, so this is a gain. You have gained kinetic energy. क्लियर हुआ दिमाग में ये पॉइंट?
नहीं, ठीक है।
नेट तो यही हुआ है ना काइनेटिक एनर्जी के
हाँ
पॉइंट ऑफ
हाँ,
व्यू से.
ठीक है।
ओके. एंड इफ यू थिंक व्हाट इज द कंट्रीब्यूशन ऑफ द ग्रेविटेशनल वर्क, जो ये वाला वेट है, वेट
हम्म।
उसकी पोजीशन बदली है बॉडी की.
बॉडी की
सो
पोजीशन।
तो वेट ने क्या करा है? वेट ने बॉडी की पोजीशन को चेंज कर दिया, राइट?
हाँ जी सर।
तो उसकी वजह से जो पोटेंशियल एनर्जी चेंज हुई वो कितनी है? अभी हमने पोटेंशियल एनर्जी पढ़ा नहीं, थोड़ा एडवांस लेवल क्वेश्चन हो गया. mgh लॉस है या गेन है? पोटेंशियल एनर्जी का लॉस है. यू हैव लॉस्ट योर
लॉस।
पोजीशन, राइट?
हाँ जी।
So it's negative. So the work done by the mg is this. It shows up as loss of potential energy. And what
Okay.
happens to the frictional force? जो frictional force है वो क्या करेगी? वो भी अपना work done करेगी. So whatever work is being done by the frictional force and the work done by the weight mg, right? Together, how does it show up? It shows up as the change in kinetic energy of the system.
Okay.
I will tell you another way to look at this. So this is the work done by the resistive. So if you notice, ये कितना निकला है? ये negative sign के साथ निकला है ना?
हाँ जी।
Right? So this is a loss work. It's a loss of position. So
Okay.
W, which is due to the, so you are gaining velocity, kinetic energy का gain हो रहा है और potential energy का loss हो रहा है. Kinetic energy is net is that kinetic energy is gain. Velocity has increased to this, but position का loss हुआ है.
ठीक है।
Although we have not studied this position concept, okay? So the total mechanical energy change of the system is this much. Okay, let me do one thing. Let's wait before you reach this stage of potential energy. Let's only do questions where you have involvement of kinetic energy only. That's all. Let's not do potential energy too. Otherwise you won't be able to think. So let's do something which you have done as a concept. दोबारा से वही height और दोबारा वो शुरू हो जाएगा. रुक जाओ. So let's say there is a body whose linear momentum increases by, okay, so we are dropping this question for a while because when we do the conservation, last topic is when we will learn this. It's too early. So let's say we do this momentum. So there is a body which has a momentum of P. It undergoes a change in momentum, which means an external force is applied on it. And the momentum of the body now increases by 20%. So the new momentum is 1.20 P. So this is P initial and this is P final. So by some application of some external force. The question is, how much is the change in kinetic energy percentage?
Okay.
ये कितना आएगा? और obviously I am referring to the kinetic energy can be expressed as P square by 2m. ये formula use करके. So you have to find KEF and KE initial, subtract and calculate the percentage change which momentum is exhibiting. Momentum change हुआ मतलब kinetic energy भी बदली. मास तो बदल नहीं सकता, तो velocity बदली है. Actually, if you say the momentum has gone up by 20%, if the
हाँ जी।
mass is same, the velocity has gone up by 20%. So in a half mv square scenario, the changing percentage is something to do with v square, which means 1.2 v square, 44%.
Okay.
सही कह रहा हूं ना मैं?
हाँ जी, हाँ जी।
If you don't apply this formula and you think logically, in a kinetic energy expression, you're half mv square. The only way you can change the momentum is by increasing this by 1.2, right? और क्या तरीका है momentum के अंदर, right? It's mass into velocity. The new is 1.2 into m into v. Mass तो बदला नहीं, तो this is 1.2 into v. सो 1/2 इंटू m, तो ये 1.2 टाइम्स हो गया अब नया. So how much this becomes? It is 1.44 times the initial kinetic energy. So your kinetic energy final minus initial will become 44%. 1.44 minus 1 divided by initial kinetic energy. परसेंटेज हमेशा इनिशियल से कैलकुलेट करते हैं. 44%. ये लगाना है डायरेक्टली, ये लगा लो, ये लगाना है ऐसे लगा लो, मर्जी है. Okay, now you do this. Now the question is the kinetic energy of the body increases by 300%. एक बॉडी है, उसकी काइनेटिक एनर्जी increases by 300%. What is the percentage change in its momentum? You have to calculate delta P percentage. मतलब delta P divided by P initial into 100. And this is delta KE percentage which is given to you. Delta KE upon KE initial is 3 into 100 is 300. You can use this if you want to.
डेल्टा के ई अपॉन डेल्टा के ई इनिशियल आ जाएगा 3
3 times, right?
हाँ जी.
Change is 3 KE.
यस सर.
If it is increased by 300%, if something increases by 300%, that means it has tripled, right? So delta
Yes, sir.
KE is 2 KE.
Yes, sir.
If you are X, you have become 3X.
Yes, sir.
But इसमें
Yes,
तो
sir.
परसेंटेज चेंज कितना 200% नहीं होगा,
हाँ.
है ना?
Yes.
So if I say my kinetic energy has increased by 300%, what do I mean? I should say that my kinetic energy percentage change is 300%. और डू आई मीन ट्रिपल्ड? अगर ट्रिपल्ड है तो हमने ये लिखा हुआ है. अगर 300% है तो x के ऊपर 300% इंक्रीज का क्या मतलब है? 4x. If the
Yes, sir.
kinetic energy of a body increases by 300%, then probably we mean triple.
Yes, sir.
ट्रिपलिंग हुई है तो मतलब ये वाला ठीक है, इसको ले लेते हैं. लैंग्वेज थोड़ी क्रिप्टिक है, बट लेट्स से दिस इज द वन. मे बी डजंट मीन दिस, दैट द चेंज इन परसेंटेज इज 300. चेंज इन नहीं लिखा ना, चेंज. It says the kinetic energy becomes 300% of its initial. That means tripled.
Yes, sir.
Poor language used.
ठीक है.
Bad. ठीक है. Now calculate delta P by Pi.
डेल्टा पी है. डेल्टा डेल्टा पी लाइक वो होता है ना, क्या कहते हैं,
वो यूज कर लो. K is equal to P square by 2m.
K इक्वल्स टू पी स्क्वायर बाय 2m. ठीक.
पता है ना, पता मैं. We know that, right? Kinetic energy क्या होती है? Kinetic energy is equal to P square by 2m.
हाँ मैं लिख रहा हूँ.
हम्म.
K इनिशियल हो जाएगा.
उसमें लिखो ना के, हाँ ऐसे लिख लो. के फाइनल इज 3 times. सो 3 KE लिख लो. मेक इट 3 KE डायरेक्टली. हाँ 3 KE इनिशियल.
सर जस्ट मैं चार्जर लेके आया.
इसको 3 KE लिख लेते हैं ना यहाँ पे. आई, राइट? आई ट्रिपल्ड हो गया, अब P2 निकाल लेते हैं.
हाँ ठीक
Let's
है.
calculate P final.
3ki equals 3 of
Not 3. How do you know? No. P2 तो निकालना है ना हमने नया.
अच्छा.
हमें तो पता ही नहीं अभी. कोई भी नाम रख लो उसका, X रख लो, P final रख लो, कुछ भी रख लो यार. Then divide the two equations and get PF and PI relationship. PF और PI का relationship आ जाएगा. PI, यहाँ PF लिख लो ना, PF
ठीक है.
by 2m.
तो
Divide these two. So PI square upon PF square is equal to 1 by 3.
1 इसको इससे डिवाइड कर लेते हैं ना, इसको
उल्टा
इससे.
कर लो. आई एम गुड. No problem. So PF square
is equals to 3.
3. So root 3. So P final is root 3 times PI, which is 1.732.
सर जस्ट एक मिनट.
So 73% gain हो गया ना over
हाँ.
PI.
यस सर. यस.
Done.
ठीक है सर.
Okay, so this is what we will do. We will continue to do some numericals on this, and then we will move to the next topic of potential energy. Once we clear the hurdle of potential energy, we will club both the mechanical energies and then start doing questions which are bit tricky. जिसके अंदर the work done will also result in another change of mechanical energy which is potential. तो आज जो हम कर रहे हैं अभी kinetic energy से करते रहेंगे. फिर we will introduce the topic of potential energy, and then we will club the two and say now the questions include multiple forces, each doing different type of mechanical work, and how to make a equation where we can hold the law of conservation of energy true, which means the mechanical energy remains conserved and is available sometimes in potential energy, sometimes in kinetic energy, or mix of these two, and how is it related to the external work we are doing. This is a total chapter all about. Tricky chapter, small chapter. फिर collision हमने कर रखा है. We will revise numericals of collision because we just have a view of super elastic collision, etc. लेकिन हमने कोई numerical नहीं करा हुआ coefficient of restitution पे. And the last topic is power.
बल.
ठीक है जी. See you tomorrow then.
सर एक चीज बताओ सर.
बोलो.
एक चीज पूछना था. ये लाइक जो पोटेंशियल एनर्जी का फॉर्मूला है mgh, सर उसके जो डायमेंशन वो सिंपल वर्क डन जैसे भी है.
जूल ही तो होना चाहिए ना. Should be joules.
अच्छा.
Should be joules. Newton into height.
तो भी
mg is
इसका
Newton.
वर्क डन नहीं हो गया पोटेंशियल एनर्जी.
हाँ मतलब unit wise तो same है, but it is appearing in the form of capacity to do something.
ओके.
If you are at a height and if I drop you, you have the capacity to do work. But तब तक तो वो आप में stored रहेगा ना work done जब तक आप height पे बैठे हुए हो. If you're sitting at a height, your bottle is on the surface of the table, then what is happening? You have stored your work done in the form of potential. किसी ने तो काम करके ऊपर रखा है ना उसको. So that work done gets stored in the potential energy. Sometimes the same work accelerates our body, and therefore we say it has converted the work done into kinetic energy. And sometimes on an incline, when you push the box on an incline, you may be doing work against friction, against mg sine theta. That is one work you're doing. And second work you're doing is also raising the position of the block to a certain height. So there are three works being done. One work to overcome friction, second work to accelerate the body up, the third work to change the position of the body, which is the height, mgh. So the total work you're doing will appear finally at the top as half mv square plus mgh.
ओके.
तो वो वर्क डन है तो जूल दोनों साइड पे. Yes, joule है, but it appears in different forms.
ओके.
अगर एक ब्लॉक पड़ा हुआ है तो nobody is doing work on it, right? But when you do work on the block, it raises the height and it reaches the position. That work is getting stored in the form of potential energy because you have raised its height, some work was done. तो ये conservation of जो energy का concept है और या work energy transformation बोलते हैं, मतलब work करते हैं तो जाता कहाँ है वो? The work done gets converted into energy provided the force involved is a conservative force. And energy can be, you can obtain back that energy as a work done also. But अगर आपने work done करा against friction, can you get it back? If it's a frictionless surface, you push the body up and then leave the body. Will it come down?
Nope.
Will come down, right? With the same velocity with which you threw it. Same, जिस velocity से धक्का दोगे, मतलब हाफ mv स्क्वायर दोगे, वो ऊपर जाएगा, रुक जाएगा, वापस आएगा और दोबारा से हाफ mv स्क्वायर 5 जूल से वापस आ जाएगा. बट अगर रास्ते में उसको एक नॉन कंजर्वेटिव फोर्स मिल गई, जैसे कि फ्रिक्शन, will it come back with the same velocity? No, there will be a loss. Agreed?
Okay. Yes.
Right? So हमें वो देखना पड़ेगा जब हम क्वेश्चन सॉल्व करेंगे. अब एक डायमेंशन आ जाएगी लॉ ऑफ कंजर्वेशन ऑफ एनर्जी के अंदर कि अब फोर्स जो लग रही है वो कंजर्वेटिव फोर्स नहीं है, वो नॉन कंजर्वेटिव फोर्स है. इस फोर्स के पास ताकत नहीं है कि ये वापस जो भी आपने एनर्जी स्टोर करके पोटेंशियल एनर्जी पे रखी थी, ऊपर जाते हुए भी लॉस हुआ था और नीचे जाते हुए भी लॉस हो जाएगा. तो आपने हो सकता है बॉडी को 20 जूल से फेंका हो और नीचे आते वापस में सिर्फ 2 जूल मिले, मतलब 9 जूल का लॉस अपवर्ड फ्रिक्शन में, 9 जूल का लॉस डाउनवर्ड फ्रिक्शन में, और नेट आपको सिर्फ 2 जूल मिला. इसका मतलब वो कोई फोर्स ऐसी थी जो नॉन कंजर्वेटिव इन नेचर थी. उसने कुछ ऐसा काम करा कि इसकी जो टोटल काइनेटिक एनर्जी है वो नेट कम हो गई. तो हमें मालूम चल जाएगा व्हाट वाज द वर्क विच इज डन बाय द फ्रिक्शन. 18 जूल. 20 joule is equal to 2 which you see and 18 which you lost. We will do many numericals, don't worry. Abhi just let's begin with the kinetic energy and then progress into potential, then combine the two, and then let's get into conservative force as another added layer on top of this and solve questions of work power, work energy, saying this is a scenario of conservative force, this is a scenario of non-conservative force. How to adjust and solve the questions. ठीक है जी? चलो, see you tomorrow then.